Hey there, welcome back. So, in our last explainer, we threw around this idea that deep learning is like a super smart team of specialists. They all work together in layers to crack a tough problem, like figuring out if a photo has a dog in it.
But that kind of begs a really big question, right? How is that team actually put together? I mean, what's the secret blueprint that lets all these different specialists work together so seamlessly?
Well, the answer is a piece of tech that's right at the heart of all deep learning. It's called a neural network. And honestly, it's the framework, the structure that makes this whole thing work.
Okay, AI's digital brain. And yeah, the name neural network might sound a little intimidating, but the core idea, well, it's inspired by something you're using right this very second, your own brain. So think about it. Inside your head, right now, you've got billions, literally billions of tiny cells called neurons. They're all connected. And when you see something or hear something, they fire off signals to each other, creating this incredible chain reaction that lets you recognize patterns and make sense of the world. So what's an artificial neural network? Well, it's pretty much what it sounds like. It's a digital version of that process. Instead of biological neurons, we have artificial ones. We usually just call them nodes. And the whole system is designed to copy or mimic the way our own brains process information. All right, let's meet the team. Remember that team of specialists analogy we started with? Well, if deep learning is the whole team, then the neural network, that's its org chart. It shows how everyone is connected, and every single specialist on that chart, that's an artificial neuron. So where does the work start? It all begins right here, at the input layer. Let's call these guys the pixel detectives. Seriously, if you feed the network an image, each one of these neurons has just one job, to look at one tiny piece of the puzzle, like the brightness of a single pixel. That's it. Okay, once our detectives have done their job, the info moves on to the hidden layers. And this, right here, is where the real magic starts to happen. This is where pattern recognition kicks in. The secret sauce? Specialization. You don't have one neuron trying to find a whole face. No way. You have groups of them, each looking for something super small and simple.
So picture a single neuron in one of these hidden layers. It's getting all these signals from the layer before it, and it's basically asking itself one simple question. Based on everything I'm seeing, how sure am I that I'm spotting a specific pattern? It's just trying to decide if it sees something simple, like a straight line, or maybe a curve.
Now this information keeps passing from layer to layer, with each one combining simple patterns into slightly more complex ones. And after all that work, everything finally lands at the last stop, the output layer. This is the big boss, the director. The director doesn't care about individual pixels anymore. Its job is to look at all the reports from the pattern finders and make the final call. And this is what that final decision actually looks like. The director has seen tons of evidence for dog-like features. Ears, a snout, fur. So the dog neuron fires with a whopping 98% confidence. The cat neuron, barely a peep, just 2%, and bam, the network has made its choice. It thinks it's a dog. Okay, from pixels to patterns, this is maybe the most important idea to get. The network doesn't just instantly see a dog. It can't. Instead, it builds the idea of a dog, almost like it's assembling it from scratch, piece by piece, layer by layer. And this shows you exactly how it works. It's beautiful, really. Layer 1 just sees the raw data, the simple pixels. The next layer takes those pixels and says, hey, I see lines and curves here. Then, the layer after that combines those lines and curves to form more complex things, like eyes and noses. And finally, a layer down the line puts all those pieces together and goes, aha, that's a face. So this might all sound a bit abstract, but here's the thing. This is not just theory. This exact structure is the engine humming away behind a ton of the AI you and I use every single day. Think about it. When you talk to Siri or Alexa, a neural network is figuring out what you mean. That facial recognition that unlocks your phone? Yep, powered by a neural network. And all the crazy generative AI and language models we're seeing now, they're built on these massive, unbelievably complex neural networks. I mean, they're everywhere. So yeah, it's pretty clear how fundamental this stuff is. Let's do one last thing. Let's zoom all the way out and see exactly where neural networks fit into the grand scheme of AI. Let's put all the pieces together. Okay, this is it. This is the big takeaway. Artificial intelligence, that's the big overarching goal, right? the dream of smart machines. Machine learning is one way we try to get there. Deep learning is a super powerful type of machine learning. And what makes deep learning work? Neural networks. They are the fundamental brain-inspired structures at the very bottom of it all. They're the building blocks.
So we've totally unpacked the blueprint. We get the structure, we see how the team processes information from pixels all the way up to a final decision. But that leaves one giant fascinating question hanging in the air. How does this network actually learn? How does it get smarter over time? Well, that's exactly what we're going to dive into in our next explainer. I'll see you then.